Good day everyone. Today I am going to discuss the infinite series. Infinite series. Let S sub n be an infinite sequence. We can form the infinite sequence of a partial sum S sub n as follows. S sub 1 is equals to S sub 1. S sub 2 is equals to S sub 1 plus S sub 2. S sub 3 is equals to S sub 1 plus S sub 2 plus S sub 3. S sub n is equals to S sub 1 plus S sub 2 plus S sub n, and so on. We usually will designate the sequence S sub n by the notation summation of S sub n is equals to S sub 1 plus S sub 2 plus S sub n, and so on. The numbers S sub 1, S sub 2, and S sub n will be called the terms of series. Consider the sequence ER raised to the power of n minus 1, which consists of the terms A times R, A times R squared, A times R cubed. The series summation ER raised to the power of n minus 1 is called a geometric series with ratio R and the first term A. Its end partial sum A sub n is given by A sub n is equals to A plus AR plus ER squared plus ER n minus 1. Theorem 43.1. So I get this theorem in the reference given by our instructor Sir Canida. Given a geometric series summation of ER n raised to the power n minus 1, if absolute value of R is less than 1, the series is converges and has sum A over 1 minus R. So this is the formula. If R is greater than 1 and A is not equals to 0, the series will be automatically diverge to infinity. So, and if R is less than 1, the series is convergent. I have here example number 1. So 4 plus 8 plus 4 plus 2 plus 1 plus 1 half plus 1/4. So what are you going to use? What are you going to do now? First is identify the common ratio and the A sub 1. So in getting the common ratio, our formula for that is A sub 2 over A sub 1. So A sub 2 here is 4, and A sub 1 is 8. So we can substitute 2, A sub 2 is 4 and A sub 1 is 8. So 4 over 8, that is equals to 1 half. So our ratio is less than 1, so we can use this formula. And our first term is 8. So substitute is equals to 8 over 1 minus the ratio, which is 1 half. So cancel this. So this will become 8 times 2 is 16, and 2 times 1 is 2. That this is not raised to the power of, that is 2 minus 1. So 2 minus 1 is 1. 16 over 1 is 16. So our answer is 16. The sum of the geometric series is 16. Example number 2. The summation notation of 4 over 5 raised to the power of n minus 1 when n is equals to 1. So first is we need to list out the terms. So in listing out the terms, we need to substitute the value of n. So when n is equals to 1, so 4 over 5 raised to the power of n minus 1, that is equals to 4 over 5 raised to the power of 0. So when any number raised to the power of 0, that is equals to 1. Next, let n is equals to 2. So 4 over 5 raised to the power of n minus raised to the power of n 2 minus 1. So 2 minus 1 is 1. So our second term is 4 over 5. Wala ni 0 3 guys. 4 over 5. And let n, we need to get the third term. So let the value of n is equals to 3. So 4 over 5 raised to the power of 3 minus 1, that is 2. So So 4 over 5 raised to the power of 2, that is equals to 16 over 25. So this is our third term. And our ratio is 4 over 5 because 4 over 5 over 1, that is equals to 4 over 5. So that's why our ratio is 4 over 5. And our A is 1 here, 1. So we can use this formula because 4 over 5 is, can use this formula because 4 over 5 is less than 1. So is equals to A over 1 minus R. So 1 times, substitute the value of A sub 1, which is 1. 1 over 1 minus the ratio, which is 4 over 5. So 1 times 5 is 5. So cancel this. So 5 times 1, 5 minus 4. So 5 minus 4 is 1. That's why 5 over 1. So our answer for this, for the sum of this series, is 4 over 5. Example number. So to find the common ratio and the first term, we can use this. We can use this formula to find the common ratio and the first term. So this form, n, the summation of 4 over 5 raised to the power of n minus 1 when n is equals to 1. So n is equals to 1. And this is our ratio. And in front of our ratio is our A here. That's our A. And same n minus 1 and n minus 1. So when you encounter this form, we can use this formula in solving this problem. Example number 3. The summation notation of 8 times the quantity of n over 3 n raised to the power n minus 1. So n is equals to 1. So this form, we can use this formula because the two is just the same. So this is our first term and this is our common ratio. So substitute our first term, which is 8. So 8 over 1 minus the common ratio, which is 2 over 3. So 8 times 3 is 24. And these 2 will become cancelled. So 3 minus 2. And 3 minus 2 is equals to 1. So 24 over 1, that is equals to 24. So the sum of the geometric series is 24. So example number 4. So our example number 4 is now different from example number 3. So when you encounter this form, you can use also this formula. So the summation notation of 4 times the quantity of 2 over 5 raised to the power of n when n is equals to 0. So as what you can see, this form and this form is just the same. So we can use this formula. And the formula is the summation of ERN when n is equals to 1. I mean when n is equals to 0. This is equals to a sub 0 over 1 minus r. We start from a sub 0 because the value of n is 0 and not start from n is equals to 1. So that's why we put this a sub 0. So substitute 4. A sub, our a is 4 here and our ratio is 2 over 5. So substitute 4 over 1 minus our ratio, which is 2 over 5. So multiply both denominator and numerator by 5. So 4 times 5, that is 20. And 5 minus 2, that is 3. So 20 over 3. So the answer for this geometric series is 20 over 3. So here in our example number 5, So the summation notation of 4 raised to the power of n plus 2 raised to the power of n over 5. So what are we going to do now in this kind of form? So this form is, we need to split this into two geometric series. So our first geometric series is this. So the summation notation of 4 over 5 raised to the power of n when n is equals to 1. And our second geometric series is this. The summation notation of 2 over 5 raised to the power of n when n is equals to 1. So in this form, we cannot use those two formula. We cannot use this formula and this formula, because as what we can see, even though it is n is equals to 1, but the exponent is n minus 1 and the exponent here is only n. And even though the exponent here is only n and here is only n, but the value of n is not 1, and the value of n here is 1, and the value of n in this formula is not 1, and this is 0. So we cannot use these two formula in solving this. So what are we going to do now is find the first term or list out the terms. So in finding the first term, we need to substitute the value of n, which is 1. So 4 over 5 raised to the power of n, substitute the value of n, which is 1. So our first term will be a, here the summation notation of n over 5 raised to the power of n when n is equals to 1. So the first term is 2 over 5. And by looking this two, the common ratio is less than the common ratio for these two is less than 1. So we can use the formula is S is equals to A sub 1 is equals to S is equals to A sub 1 over 1 minus R. So so A sub 1 plus A sub 2. So substitute the A sub 1 is 4 over 5. Here 4 over 5. And the A sub 1 here is 2 over 5. Substitute. So over 1 minus 4 over 5, which is our ratio, because our ratio here is 4 over 5 and ratio is 2 over 5. So substitute 4 over 5. And 2 over 5 over 1 minus 2 over 5, which is the ratio. So next is multiply both numerator and denominator by 5. So cancel this, cancel this, cancel this, cancel this, cancel, and cancel. So the remaining will be 4 over 5 minus 4 plus 2 over 5 minus 2. So 5 minus 4, that is equals to 1, and 5 minus 2, this equals to 3. So 4, that's why 4 over 1 plus 2 over 3. So we need to add this 2. So this will become 12 over 3 plus 2 over 3, and 12 plus 2, 14. So 14 over 3. So this is our final answer for this two summation, for this geometric series. And I have here some exercises for you to answer and be practice of what I've been discussing to you earlier. And that would be all. Thank you.